Hello everyone, my name is Jacob Peroni and I'm here to introduce topic detection in NLP. I chose this topic for my presentation as I found it interesting and I really like that it can encompass a wide application domain. So what is topic detection? Topic detection allows automatic meaning extraction from text by identifying themes or topics. Topic detection can also be equated to topic analysis, which uses machine learning to organize and understand large collections of text data. And they do this by tagging or assigning categories to each of the text topics. So for instance, you can tag one text as health when its contents relates to working out or nutrition, or you can tag another text as finance when that text relates to, say, the stock market changes. So natural language processing is used to find the patterns and semantic structures in text so that insights can then be extracted. And then those insights can further be used to make data-driven decisions. Topic detection is mainly used as a fast and cost-effective way to analyze large text data, as manual labeling is very time-consuming and overall more expensive. Topic detection is used in areas such as document clustering, organizing of textual data, information retrieval of unstructured data. An example that can be used from recent times is the New York Times using topic detection to enhance their news article recommendation system. It can also be found in businesses to analyze internal documents, or it can be used with communications with customers. It can also be used with other NLP aspects, such as sentiment analysis relating to product reviews. Some other areas that topic detection can be used also include social media monitoring, customer service, sales and marketing, even search engine optimization. The scope of topic detection can be applied to a document level, a sentence level, and a sub-sentence level. The document level obtains the topics from the complete text, so such as taken from an email. The sentence level obtains the topic of a single sentence, so you could think of it as like a news headline. The sub-sentence level obtains the topic of sub-expressions within the sentence, so you can think of like a product review that has multiple topics in a given sentence. So some of the challenges of topic detection include the following. The varying length of text documents is a challenge, as different algorithms can perform better depending on whether it's a long text document or a short text document. The lack of consideration for abbreviations or slang usage, as opposed to just structured sentences, is a key challenge. Language interpretation, such as using sarcasm or metaphors or similes, um, those rely on previous knowledge or context, can impact the classification of topics. And the complexity and sparsity of the data can also play a role in topic detection. Many of these challenges do stem from short text documents, and that's because there's a lack of contextual information in those short text documents, which will then lead to the data sparsity problem. So looking at some of these solutions for topic detection, the first one I'm going to look at is the topic modeling approach. So the topic modeling approach is an unsupervised learning approach, and it's used when you want to find out the different topics covered in a set of text documents and group them by those topics. They work by assuming a mixture of topics and finding how prevalent each topic is in a given document. So this is done by grouping documents based on the words they contain and then finding the correlations between them. This is very similar to cluster analysis, but there is a distinction between the two. Two popular algorithms used in the topic modeling approach are latent semantic analysis, or it's commonly called LSA, and then latent direct allocation, or LDA. Both of these are going to be talked about on the next slide in a little bit more detail. So the next approach is called topic classification. With this approach, this is a supervised learning approach, and it's used when you already know the topics that you're looking to classify. This approach is good when you want to automate a human-dependent process. So to give you a good example of this, you can apply this approach to say to route support tickets by topic to the correct person on the customer service team without actually having to sift through them manually. So some algorithms that can be used for topic classification include the multinomial naive Bayes. Also, you can use support vector machines and deep learning. I want to touch on the deep learning a little bit more. So the deep learning architecture you can use are conventional neural networks, or CNNs, but you can also use recurrent neural networks is very popular as well. Those are RNNs. So looking at the next part, the short text in particular is a key problem as it contains most of the challenges in topic detection. So you can use short text aggregation, so in word embedding, to kind of remedy the short text problem. So text aggregation will aggregate the short text for data sparsity. So even though it does take all of the short text together, you do have a problem with that in that all of its numbers of parameters increases with the data size. And it's also very prone to overfitting, and overall just becomes really computationally expensive. Now, the word embedding is used for word representation in a vector space, and by encoding syntactic and semantic information as similar words are closer together in the vector space. This helps combat the sparsity and is typically processed through a neural network. Okay, so I just want to go into a little more detail about the topic modeling algorithms, LSA and LDA. So starting with LSA, LSA is based on the distributional hypothesis, and the distributional hypothesis can basically be summed as words and expressions that occur in similar pieces of text will therefore have similar meanings. LSA also uses TF-IDF as the word frequency. It just yields a better representation of words inside the documents. The resultant document term matrix has all the information that we want. It has a document topic matrix and a term topic matrix. So these matrices hold the information about the topics of the text, which is what we're after. So to get to them, we have to decompose the document term matrix into three matrices using what's called truncated SVD. So regular SVD is a linear algebra algorithm for factorizing a matrix into the product of three matrices. So the middle matrix is important as it is a diagonal matrix of singular values of the original matrix. So every singular value is a potential topic. So then truncated SVD will select T columns of the first matrix and T rows of the third matrix to reduce dimensionality of the decomposition. The idea is that the most important topics are the ones that are being selected. So then the resulting vectors of these matrices represent the documents expressed with topics and the terms expressed with topics, and can be measured with using like the cosine similarity to be as an evaluation metric. So now moving over to LDA. LDA is based on some advanced mathematical probability techniques, which can get a little too technical than what I really want to go into. So I'm going to explain more so the overall idea of it here. So Pictures say if we have a fixed set of topics that are represented by an unknown set of words, then these become the topics our documents will cover. And we don't know that yet. We don't know what they are. So what LDA is going to try to do is it's going to try to map the known documents to the unknown topics in a way that the words in each document are mostly captured by those topics. So the fundamental assumption here is the same as LSA, and it's also assumed that every document is composed of a mixture of topics, and every word has a probability of being in a particular topic. So LDA assumes that documents are generated by picking a mixture of topics and then picking words that belong to those topics. And the words are picked at random. So LDA works almost backwards from the words that make up the document and tries to guess the mixture of topics that resulted in the arrangement of those words. The output of LDA is a vector that uh, it's a vector that consists of every document with its mixture of topics that each particular document would have, essentially. So this is just the references that I used throughout the previous slides. And here I have links for more insight into topic detection. Some of these also have some guides as to start, practicing with topic detection on a more small scale. A few of them are used in Python. Um, I believe one of them also you can do inside the web browser. But these are just some extra links if you're interested to check out to learn more, practice with it, if you think you can apply topic detection to your area. Thank you all, and I hope you all have a great day.